Hello everyone, I'm Steve Lee. I'm with Bitcoin Optech, and I'm here to present the next Softfork, which is really just talking about potential upcoming changes to the Bitcoin consensus protocol and how they may impact users and businesses of Bitcoin and what benefits it might bring to various services. First, let me step back and talk about the life cycle for how does a change even occur to the Bitcoin consensus protocol. It begins with innovation, and that can be one or more developers who see a potential change that can improve Bitcoin. They work on it, they develop it, iterate it on it, and once they're comfortable that it's a good change and is secure, they publish it in a BIP, a Bitcoin improvement proposal. That makes it public for scrutiny and feedback from the larger and broader ecosystem, which moves on to the next phase. And that can be technical feedback from other open source developers at businesses. It can also be non-technical feedback from business owners, hobbyists, investors, anyone in the Bitcoin ecosystem. And once that phase is complete, that may involve a lot of iteration and improvements. And if it's believed that there's consensus that this is a positive change for Bitcoin, it moves to the next phase, which is to actually implement it in the protocol and go through a QA phase to test it and make sure it's a safe change. Which then goes to the next phase, which is actually activating it on the network. And once it's activated on the network, then services can adopt it and begin using it. So where is the next Softfork at in this life cycle? Schnorr and Taproot is a proposed Softfork. It was proposed in early May, and probably the most well-known and popular potential change. So it was just recently proposed, so it's in the phase of getting ecosystem feedback. And most of today's presentation will be talking about Schnorr and Taproot. However, there are a couple other proposals that deserve mention. One is called the Great Consensus Cleanup. This change was, this proposal was made in March, and so it's in the ecosystem feedback phase. It also has an implementation already, so it's a little bit more mature in that sense. I'll touch on that to at least let you know what is involved with that. And lastly, there is the SIG hash no input proposal, originally part of Schnorr and Taproot, but it is now separate because it's not quite as mature in development. So it is it still has a few issues, technical issues that need to be ironed out before being officially proposed. So as I mentioned, I'm going to spend most of the presentation time on Schnorr and Taproot. So let's dive into that. So what's the motivation for this change? Why should it interest businesses and users? There's some really compelling aspects to this proposal. One is that it's a big improvement for scaling, in particular for multisig applications or sophisticated smart contracts that might have many different ways to spend Bitcoin. Multisig wallets can expect to save anywhere from 30 to 75% on fees. So if you're a high volume exchange which uses a multisig wallet, let's say you do $300,000 worth of fees every month, by implementing this, you could look to save upwards of like $100,000 a month. So it's potentially very material to businesses. Another motivation for this change is fungibility, and with Taproot, all outputs for spending look identical, and most spends are indistinguishable. So this is a big improvement for fungibility, in which you could have a lightning channel open or close, a simple payment between two people, or a very sophisticated smart contract, and they are all of a sudden become indistinguishable by spending it using Taproot compared to past methods to spend with Bitcoin. And lastly, using Schnorr signatures allows tweaking of signatures and keys, which really opens up a whole new world of innovation and possibilities that I think we're only scratching the surface on right now. Also with this proposal, all of a sudden very large K of n multisig wallets become economical and possible. And most limitations for the number of scripts that can be used to spend coins also goes away, which opens up a whole world of new possibilities. So let's talk a little bit about Schnorr signatures. They are pretty much in every way better than the current ECDSA signatures in Bitcoin. So why weren't they originally in Bitcoin? It's thought that Satoshi did not include them because they were patent protected up until about when Bitcoin was initially released. The patent has expired since then, and for many years, a lot of people in the Bitcoin space have been eagerly awaiting getting Schnorr signatures into Bitcoin. They're about 11% smaller than the existing signatures. They're compatible with existing private keys, so it should be relatively painless to upgrade to Schnorr. It's based on the same security assumption, so there's no change in the security model behind Bitcoin. But the most important thing about Schnorr is that it enables key aggregation. So for example, if you have Bitcoin that's protected by 3 keys, Alice, Bob, and Charlie, what Schnorr enables you to do is aggregate those 3 keys into a single aggregated key. And a certain mechanism needs to be used to accomplish that. One such mechanism is Musig, but others are possible. Throughout this presentation, I'll refer to Musig as the mechanism, largely because it's been proposed as well and published, and I think it's one of the more mature mechanisms to achieve this. But through a process like Musig, you can aggregate all 3 keys into a single Schnorr, into a single key, and a single Schnorr signature can then spend those coins. So what kind of impact can this have on a 2 of 3 multisig transaction? Well, today, when you go to spend a 2 of 3, in that transaction that you broadcast, you need to include all 3 keys that are part of the transaction, and at least 2 signatures to spend the coins. That's a total of about 240 bytes worth of data. With Schnorr, all of that can be condensed into a single Schnorr signature, which is only 64 bytes. So you can see substantial savings. Now, it should be noted, there's a lot of other transaction overhead that I didn't show in the slide. I just wanted to focus in on what the actual changes are, what Schnorr enables. But you can get a feel for how much more efficient it can be. A multisig wallet and transaction could be done with Schnorr. Okay, that's a little bit on Schnorr. Now let's talk about Taproot. So what is Taproot? Taproot is a new way to spend Bitcoin. It's a standard, a proposed new standard script. If you're familiar with what one of the benefits that SegWit brought, it added script versioning. So Taproot would be a version 1 script. We're currently on version 0, so this would be a V1 script. And it can be, pay to Taproot can be used to spend any type of coins. This presentation is largely going to focus on multisig because that's where the large benefit is seen. But do keep in mind that even a single key spend can be used with pay to Taproot. And there's advantages to using pay to Taproot for all spends, because as you'll see throughout this presentation, all outputs look identical with Taproot, so it helps with Bitcoin's fungibility property. So let's walk through an example. So let's say we have an exchange with a hot wallet that's a 2 of 3 multisig design. In this particular use case, the exchange has a hot key. It also relies on a trusted third party for a hotkey, and those 2 keys are, that's the primary way to spend this wallet. So most spends of this wallet are those 2 keys. However, there's a third key that's an emergency backup key that's stored in cold storage in case one of the other 2 keys becomes unavailable. So I'm going to walk through 2 different designs using Schnorr and Taproot to accomplish this use case. The first one is using what's called threshold signatures. So what is that? Well, we have the three keys that we just discussed, and we ultimately want to we want to aggregate those keys into a single key for our key setup. And with threshold signatures, the process of creating that single key requires interactivity. So it's an interactive Musig threshold setup that not only aggregates these three keys into a single key, but it also makes it so that any two keys can be used to sign off and create a single signature to spend this output. Let's see what spending looks like in this case. So to spend using threshold signatures, you take two signatures. In our example, again, the primary way to spend is using the exchange hotkey and the third-party hotkey. So we take those two keys, create signatures. Those two signatures are then aggregated into a single signature, this Schnorr signature, and that's all that's needed to validate a transaction against the taproot output key that we previously showed. So what's broadcast on chain and what's observed by any Bitcoin full node is simply this one output, which contains a single key and the single Schnorr signature. So that's very powerful. So again, any two of those three keys can produce signatures, but ultimately what's broadcast and viewed by the rest of the world and any Bitcoin node is just a single signature, just a single key. So extremely great for scaling. This reduces the transaction size significantly, which saves you fees, and it has really nice privacy and fungibility properties as well. Now, there are a couple drawbacks to this particular approach with using threshold signatures. Number one is we showed in the previous slide that it requires an interactive key setup. So for some applications, that'll be perfectly fine. For other use cases, maybe that's a non-starter. The second drawback is that you lose accountability with this approach. So using threshold signatures, we no longer have cryptographic proof of who the two signers were for this transaction, because all we have is the single signature. So we don't know if the exchange and third party signed, or if the cold wallet backup key was used to sign. So if that is a requirement for your application, then we need to look at an alternative design. So let's look at that alternative design, which addresses those two drawbacks to threshold signatures. But before doing so, let's step back and look at a concept called MAST, because this is important to fully understand the taproot change and this next design I'd like to walk you through. So MAST is a concept that's been around a number of years in Bitcoin circles, and people have wanted to see this in Bitcoin, but to date it's just been a concept. It's now part of the concrete taproot proposal. So what is MAST? Well, for this particular example we're walking through, in many other situations where you want to spend your Bitcoin, you actually have multiple scripts that could be used to spend your Bitcoin. So in this case, you have a primary spending script, which in this case is the exchange hotkey and the third-party hotkey. And then you might have alternative spending scripts, one or more. In this particular use case, there's two alternative spending scripts. Now, using standard Bitcoin scripts, you actually have to reveal all scripts that are part of that are possible to spend the coins, even though only one script is actually used to spend the coins. So that produces a larger transaction, higher cost and fees, and you lose privacy by having to broadcast all the possible scripts. But with MAST, what can be done is you can hash each of the scripts, roll them up into a Merkle tree. So if you're familiar with Merkle trees from the Bitcoin design, the same concept can be applied to these scripts. And what this enables then is that when you're spending, you only use one script. And in this example, let's say the primary spending script is used. When you broadcast that transaction, you only need to reveal the script that's used. You don't need to reveal any of the alternative scripts. You only need to reveal the hash of the alternative scripts. So it's a big privacy and fungibility win. It also reduces the fees significantly for these transactions. So it enables new types of wallets that can have much more sophisticated designs with many, many different scripts. So now that you have a little bit of foundation on the MAST concept, you can see how it applies to Taproot. So we're going to revisit our example of the Exchange Hot Wallet, which is a 2 of 3 multisig wallet. This time, instead of using threshold signatures, we're going to use what's called Musig keytrees. So what's important to understand with this design is that with a 2 of 3 wallet, there's 3 combinations of 2 of 2s that are authorized to spend the coins. And again, the primary way to spend in this use case, the example we're walking through, is the exchange hotkey and the third-party hotkey. So you can think of that as a 2 of 2. There's also the 2 combinations with the cold key, the emergency key that's in the cold wallet. So you can think of each of those as 2 of 2 multisigs. With these alternative scripts, which are expected to be rarely used, they can be wrapped up into this MAST, or into this MAST concept that we just walked through. And with that MAST tree, as well as the primary way to spend, you can create, when you're creating your output, you can create a single Taproot output that contains a single key that represents all of this complexity. So I skipped over a lot of cryptographic details to get to this point, but that's the end state. And this single key and single output can represent all of this complexity. Now let's walk through how we might actually try to spend coins that are sent to this output. The first way that we'll walk through to spend is using what's called key path spending, and that's the primary spending route. Again, in this example, it's the exchange hotkey and the third-party hotkey. That's the primary way to spend. So if you want to spend the coins with those 2 keys, those 2 keys would produce signatures, which are then aggregated into a single signature, which I call Taproot signature here. And that's the only thing that needs to be broadcast in the transaction in order to create a valid transaction to match the Taproot output key that we showed in the previous slide. So it's very efficient, very simple, and that's what's going to be the common spending case in this use case. But let's say that one of the exceptional cases is needed, and the cold wallet key needs to be used. In this example, it's used with the third-party key. So for some reason, the exchange's primary key is not available. Through this process, a single aggregated signature is still created, and that's used in the transaction to spend the coins. But in addition, the script that's used is also needed to be revealed, but only the script that's needed, not all of the scripts. So you could have dozens and dozens of scripts here, and only the single script needs to be revealed. But this script is needed to be revealed in order for a Bitcoin full node to validate that this is an authorized spend, because the key path was not used. Instead, this is a script, what's called a script path spend. Okay, we just looked at a couple different designs for how you could use Taproot spending for a 2 of 3 multisig wallet. The first was with threshold signatures. So in this table here, I'm just showing some trade-offs. The first row is the first design we looked at. It's great for fungibility and fees because it doesn't matter which of the 2 keys signs, you get a very compact single Schnorr signature. So it's going to be cheap, and it's going to have great fungibility properties. But as pointed out, it does require interactive key setup, and you lose accountability. So if those 2 don't work for your use case, then you can use the second design just shown, which is the key tree, which still has very good fungibility and fee properties, because for the key path spend, the primary spending path, you get just as good of compactness as with threshold signatures. Only in the alternative scripts is where you need to reveal one of the scripts. And it has the advantage of no interactive key setup, and you do get accountability among the parties that have a key. Just for comparison, there's also Musig n of n, where where like a 2 of 2 or a 3 of 3. That doesn't require interactive key setup, and it still delivers great fee and fungibility performance. And then note that all of the Musig options require the interactive signing. So when you actually sign a transaction, the signatures that are used to sign, there is an interactive protocol there. So if for some reason that is not amenable for your use case, you can always fall back and use the traditional way to do multisig transactions, but that does come at the cost of fungibility and fees. It would be similar to what it is today. So in addition to the scaling improvements and the fungibility improvements that were just discussed, there's also lots of potential innovation ahead. I've talked a lot about Musig, but again, that's just one mechanism to do the key aggregation. Musig is actually a 3-round interactive protocol which requires secret state in between rounds. So there are some complexities there. There's potential to create other mechanisms which reduce those requirements and maybe have other trade-offs. Also, as pointed out, you can have very, very large K of n. You could theoretically, you could have 50 of 100 or 500 of 1,000. I think that's going to bring on new innovation now that that's possible. And with the MAST design, it almost puts no bounds on the number of scripts you can have. So you can imagine innovation around creating computer-generated scripts with lots of different ways to spend coins, and all of that complexity is hidden off-chain and is never broadcast. Only at most one script is ever broadcast on-chain. Lastly, you might have heard of adapter signatures. They're enabled with Schnorr because of the tweaking properties of Schnorr. And with adapter signatures, all kinds of cool things could be done. For example, projects like open timestamps where you want to add data to the blockchain, that can be no longer needs to use OP return, but it can actually be added to the signatures themselves and take up no additional space. I think we're just scratching the surface on the potential innovation around the Schnorr and Taproot proposal. So let me wrap up Schnorr and Taproot with this question for you. What type of transaction is this? It has a single Schnorr signature and just one output, or an output with one key. So is this a simple payment between Alice and Bob? Is it a Lightning channel that's being closed? Or is it a very sophisticated smart contract that might have dozens of scripts behind it? Well, if you've been following along so far, you'll know that we don't know. A Bitcoin full node won't know. No observer of the blockchain will know. That's all hidden away off-chain, but we're able to validate that it is a valid transaction still. So this is really magical stuff. So I told you at the beginning that there's a couple other proposals for Softforks, and I'm not going to spend a lot of time in them, but I'll just touch on them so that you have a sense for what they are. So SigHash no input is one of the proposals, and SigHash no input it's been discussed for many years, and really what it's trying to do is just enable an improved layer 2. So it's an improvement to layer 2 protocols. Concretely with the Lightning Network, there's a proposal called L2, E-L-T-O-O, which is a pretty significant upgrade to the current Lightning design, but it does depend on a change to the Bitcoin consensus protocol, namely SigHash no input. But what that enables, it improves the user experience in a number of ways, including changing the update mechanism so that like an accidental broadcast of an older state doesn't penalize the Lightning user. It also makes Lightning more scalable. You might have heard of channel factories or multi-party channels. This is the enabler of that. So as mentioned at the beginning of the presentation, there's still some technical details of this design that are being debated and discussed to make sure it's a sound change to Bitcoin. So that needs to be resolved before proceeding with a more formal proposal. The last Softfork proposal that I'll cover is called the Great Consensus Cleanup. It was proposed in March, and it's very much system level. It's not like providing new features or functionality for services, but it's really intended to just harden Bitcoin. There's a number of long-standing vulnerabilities and sort of worst-case validation time for block issues that have been known, none of them deemed urgent for like an emergency fix. But this consensus change would address these at the consensus layer. It hardens Bitcoin. And there's, I think, 4 or 5 specific changes that are involved. So definitely read up on this if it's of interest, but it probably does not impact most services. Okay, let's talk. You might be wondering about timelines. Let's talk about an example timeline for Schnorr and Taproot. And I really want to caveat this and call out, this is just an example timeline. It's actually impossible to predict a specific timeline right now because it's a function of ecosystem feedback phase. How much feedback do we get? And what kind of feedback is it? How much does it require going back and changing the design or the specification? Is there such strong feedback that it would cause us to not want to move forward with this change? We don't know. Although it is expected with Schnorr and Taproot that the benefits are very clear and overwhelming, and there's really no known controversies or concerns with it. Okay, so we're currently in the ecosystem feedback and implementation phase, and it could be the case that it takes about 6 months to receive that feedback and implement it in the protocol and do QA and testing. It could very well take longer than 6 months as well. But in this example timeline, let's say that finishes up around the end of this year. The next phase is network activation. And at this time, we don't even know how this will be activated. There's been no proposal by anyone about how to activate the change, but that will come. And that's a variable length window. It could be activated very quickly, or it could take many months, up to a year, or again, never activated. So that's a variable length window. The third phase really is service adoption. And it overlaps with network activation because, again, within that network activation window, it could be early in that window when it activates, and then services could adopt as soon as it's activated. So conceptually, it could be as soon as this winter. More realistically, it will activate sometime in 2020. And I've highlighted in this box some of the services I think will be early adopters of this. Definitely, if you're a business that has a multisig wallet or uses or supports Lightning services, the fee savings you get with this, it makes it really a no-brainer to adopt this and prioritize adopting it. Secondly, if your service is one that promotes privacy and fungibility, or your users care about it, this definitely is a big win for that. And third, if you are a startup or you're looking to create new innovation with Bitcoin, this change really is a great platform for innovation. So I think that's a third use case that might see early adopters. Okay, next steps. Well, 3 things I would ask the audience to do. Number 1 is utilize Bitcoin Optech. We're here to help businesses scale Bitcoin. So we're here to help you with these changes and with Schnorr and Taproot. If you're a member, you're already on our Slack workspace, so feel free to ask questions there. We've done technical workshops in the past. We're going to do more, and we're probably going to have technical workshops that focus in on Schnorr and Taproot. So if you're interested in those, please let us know, and you can be involved with that. We also have the newsletter that's published every week and available for anyone to look at. If you found the technical details in this presentation lacking, please look at our newsletter. It goes into much greater depth technically and is a really great resource to understand these changes. Secondly, please engage and provide feedback. You've got a little bit of a teaser here in this presentation, but you might have a number of questions. You might have feedback based on your business, your customers, your software. Please provide that feedback. If it's technical feedback on the proposals, you can provide that on the Bitcoin Dev email list. If it's more publicly digestible feedback, you can tweet about it or however you want to give feedback. If you're not sure where to give feedback, just ask Optech. We're happy to steer you in the right direction. And the last thing is experiment and implement. These changes it's open source. It's available to be experimented with today. So if these interest you and you think it could impact your business, you can start today with experimentation and then follow along and see how it's proceeding along that timeline. And when you think it's right for your business to prioritize implementing it, you can feel comfortable doing so. That's it for the presentation. Thank you for listening. And if you have any questions, please let me know. You can also follow up with the Bitcoin Optech website for additional resources. Thank you. You can